Hey Pro Shop professionals, Alex Hoskins here with you. We'll do a quick program run through once we have all that background information about the layout adapter and the effects of the holes and the plug. And then finally, we'll test this program out with a couple different ball testers. We'll see how accurately it can identify and recommend a good converted layout that does not utilize a balance hole. So now that you have a pretty good understanding of how the plug affects the bowling ball and how those balance holes are affecting the bowling ball, we can do a run through of the program and get a pretty good idea of how these calculations are working and why it's requiring the information that it needs for the Storm Layout Adapter to give you a good recommended converted layout. First up, just like with VLS 2.0, we need that fingerprint of the bowler. We need to know exactly who they are. We need ball speed, rev rate, axis tilt, and axis rotation. Luckily, they're exactly the same as they were in VLS 2.0. That was the idea behind these two programs, is to make it very easy to transfer between the two. You'll see that we have the exact same ranges as were in VLS 2.0, so you can correctly identify the exact same player across both different programs. If you have any troubles trying to figure out how to properly input those variables or properly find those variables, VLS 2.0 will have that how-to section of videos that's going to help you properly identify each of those variables to make sure that you've correctly inputted them. Next up, VLS layout. This is one we haven't talked about much. The pin to PAP distance is going to be the first variable that it asks for. As everybody knows, that's the distance from the manufacturing pin to the positive axis point. That can safely range anywhere from 0 to 6 3/4 inches. Input that to the nearest 1/4 of an inch on there. The PSA to PAP distance is going to be the distance from the engraved PSA to that positive axis point. Okay, again, that can range anywhere from 0 to 6 3/4 inches. On a side note here, if you are drilling a symmetrical bowling ball, you'll draw a line 6 3/4 inches from the pin through the CG to find that on a symmetrical bowling ball. Now we know on a drilled symmetrical bowling ball, that is not the exact place that the PSA is going to be, but if you're drilling a symmetrical bowling ball and using this, static weights will be the only thing that's taken into account by the Storm Layout Adapter. Lastly, the pin buffer, that's the distance from the manufacturing pin to the vertical axis line. Okay, so that measurement can range anywhere from 0 to the corresponding pin to PAP distance. It cannot exceed the pin to PAP distance because we know that the PAP is always going to be on the vertical axis line. There's no way to get that further away from that line if the point of origin is already on the line. Next up, balance hole measurements. This is going to be kind of a review now from what we just did on the previous slides. So pin to balance hole, that's going to be the distance from the manufacturing pin to the center of the balance hole. We can see that that's giving us part of the equation of the location of the hole. When we add that to the PSA to balance hole distance, that's going to be the center of the engraved PSA to the center of the balance hole. Both of those measurements combined give us the exact location of that particular balance hole. So that's telling the Storm Layout Adapter where that hole is and how that's going to affect it. The next two that we'll talk about will give us the magnitude of how much that affects it. On a side note, 6 3/4 from the pin through the CG if you're using a symmetrical ball. Again, static weight purposes only. Balance hole depth, that's going to be the depth from the surface of the bowling ball to the bottom of the hole. That's giving us part of the magnitude. And lastly here, we have the balance hole size, which is going to be the total diameter of that hole. So those two combined are going to give you the total volume of material that's been taken out of that particular balance hole in that particular place. That gives the Storm Layout Adapter everything that it needs to know in order to generate a good recommended converted layout. So once you've inputted all 11 of those user inputted variables, the Storm Layout Adapter is going to give you a converted VLS layout to achieve similar dynamics in similar ball motion to a ball without a balance hole. Now that's the key here. We're not stating that it's creating the exact same ball motion. It's impossible with the orientation of the core and the allowing of using the extra hole to create the same ball motion with that. You could create so much with balance holes that you just can't do without them. The point of this program, the design intent, is to get you much closer than you would be if you simply plug that hole or if you simply drilled a new bowling ball with the same layout with no conversion. All right, now that we've proven how well this program works, last thing you need to know is where to download the Storm Layout Adapter. If we go to stormbowling.com, we go under that same brand and marketing tab that we found the VLS 2.0. We look at the left side of the screen, we see that download section. Under the drill specs, we're gonna have the Storm Layout Adapter there, free of charge for both pro shops and bowlers to try out. I urge you strongly, if you have a layout that you really liked with a balance hole, give that layout adapter a try. It's gonna give you a much more similar ball motion than just plugging that hole or utilizing that same layout without a balance hole.